Hi friends, welcome to another video. Today we are going to talk about Azure Virtual Networking. So I will talk about a lot of components on how Azure Virtual Network works. Before I start talking about this diagram, I pre-drawn this diagram just to save some time. So I'll go to this PowerPoint and show you the overall architecture of a virtual network. Okay. So when you talk about Azure Virtual Network, you have to understand the global infrastructure of Azure. So when I talk about global infrastructure of Azure, there is some component called as geographies. What is a geography? Geography is nothing but a geographical area in a specific uh, area, basically. So for example, Americas is a geography. India can be another geography. You have Australia, that can be another geography. Japan, that can be another geography. These are just geographical areas that will follow some regulatory and compliance requirement of that country. Plus your company might also be following certain compliance based on the geography you are based out of. Okay. So Americas is a geography. Within geography, you have a construct called as regions. So what exactly is a region? A region is a specific area where you have two or more data centers of Azure deployed. So if you talk about regions, it consists of two or more data centers of Azure. It helps you to provide high availability to your applications because within one region, your application may be deployed in multiple different data centers. So you can configure all of that. Now within regions, you have your virtual network deployed. In Azure, virtual network is a regional construct. If you talk about AWS or Google, uh, in AWS, I think it is again regional. But if you talk about Google, it may be a global construct as well. In Google, it is a global construct. But in AWS and Azure, you have regions, which is a construct on a specific region. Okay. So East US is the region where you'll be deploying your resources. In case of Google, you create a virtual network in one area, but you can deploy your subnets in different regions as well. That is possible. Now within regions, for example, East US is one of the regions of my virtual network. Now within East US, you will create your virtual network. When you create your virtual network, you have to define an address range for the same. So if you see 10.1.0.0/16 is my address range. And when I say /16, it'll have around 65,536 IPs in this. So you'll get a lot of IPs in this address range. So if you're deploying your workloads where you will be requiring a lot of IPs for your host VMs, you're going to go with this range. But if I require less number of IPs, I may go with a smaller range as well, maybe /24. This will give me around 256 IPs available to me. Okay. So depending on your requirement, you may go with different subnet mask. This portion is called as subnet mask. Now, once you have defined the address space of your virtual network, you also need to think about the naming convention of your virtual network. You can see I purposely named the virtual network as Vnet, which means virtual network. EUS stands for East US. App1, because this is my first application. If it is a SharePoint application, I may name it like SharePoint app. Or if it is some HR application, you may change the naming convention accordingly. If you want to learn more about naming conventions, I will recommend you go to this URL. If you go to this page, it talks about all of the naming conventions over here. Okay. So this is part of cloud adoption framework, how you move into cloud, or if you're already on cloud, what best practices which are available from Microsoft or from some third-party providers. You can find all those best practices at this one central place. Now, when you talk about naming convention, you should properly name your resources. This is again part of governance. So if you want to name your maybe a public IP, so how you can name it? You can define for public IP, you can name as PIP. SharePoint is the application that you want to create. It is deployed in production environment. It is deployed in West US region. And this is the first IP that you're creating. So all of these things you can define when you're naming your workloads. Similarly, you will find a lot of examples on this document where it talks about how you can name your other resources. So how should you name your management groups? How should you name your subscriptions? So it gives you very good examples on how you can name your resources. This is really important from a governance perspective. If you don't name your resources properly, it becomes a nightmare later on for you to manage those resources. Okay. Now let's get back to this page now. So you should name your resources properly. I include this link in the description box. You can always go to the same link to understand naming convention more. Now, a virtual network is deployed in a region, which is, let's say, East US. Within a virtual network, you will have what is called as subnets. You divide a larger chunk of network into smaller chunks, and this process is called as subnetting. Why do we do this subnetting, or why do we divide a larger chunk of network into smaller chunks? There are a lot of main reasons for it. One of the reasons you can think about is maybe you want to have different type of environments deployed. So you have like production environment will have a separate subnet. Development environment will have a separate subnet. Or you may want to segregate your application. For example, you have a web app and web app is accessed by all the people over the internet, right? If they connect over the internet, they are connecting on port, let's say 443 or 80, which is HTTP and HTTPS ports. They're connecting on these ports. You can allow that traffic on your web app, but the same traffic you can't allow over here to your database. You don't want that. You don't want anyone to connect over the internet to your database. You only want the people to connect from your web app to your database. This is allowed, but this is not allowed over the internet. Okay. So you don't want that to happen. So what you can do, you can create your web app in subnet A, and you can divide the larger chunk of network into this range that I have defined over here. So you can define this range for your subnet A, and you can define another range for your subnet B. And you can divide a larger chunk of network into smaller chunks by configuring this subnetting over here. Now, let's talk about the diagram that I showed you initially. So if you want to talk about virtual networking, there are a lot of components related to it. Okay. So what are those components available to us? Let's see them one by one. So if you see, let's say if a user is connecting over the internet. So you have a user over here, a happy user. They're connecting over the internet, although a bit creepy. They're connecting over the internet. Now, once they connect over the internet, this user gets connected to, or basically gets exposed to DDoS protection plan on Azure. So Azure will definitely have some DDoS protection plan available over here. By default, standard plan is given to everyone. So any customers who sign up to Azure, they get this standard plan by default. But if you want to get more security and you want to prevent any DDoS attack, you can go for standard plan as well. Standard plan is paid, and obviously there will be pricing associated with it. If you want to understand pricing for any service, just type the service name and then type Azure service pricing. So just type Azure, whatever service name is there. So you type Azure plus, let's say, DDoS, and just type pricing. If you search it like this on Edge, you will be able to find Microsoft documentation on pricing related to this as well. So user connects over the internet, they connect to this DDoS protection plan. Either it can be a basic plan or it can be a standard plan that they are connected to. Once they're connected to this plan, either the user is allowed to go in or they're not allowed to go in if the user is found to be malicious. If they're a bot and they're trying to connect to this network, they will be denied if it has detected that this is a bot connecting over the internet. So DDoS is nothing but it gives you it prevents any distributed denial of attacks in your environment. So you have DDoS protection plan available to you, and this will prevent any DDoS attacks within your environment. Now, besides this, you have other security measures available to you. For example, you have Azure firewall option also available to you. So in order to prevent any attacks, so you can create some policies by using Azure firewall. So these policies can be threat protection policies. So these can be threat protection policies, or these can be natting policies. So you have two types of natting policies: destination natting and source NATing. Then you can also create some network rules, or you can also create some application rules. So all of these rules can be created at a firewall level. And the priority of these rules is also like this. Threat protection rules will be processed first, then your NATing rules will be processed, network rule will be processed third, and your application rules are processed last. So there's also a priority order on how the rules are processed. So first, always these rules are processed, and as you go down to application rules, these will always be processed last. No matter what priority you give, even if you give it priority like 100, still a higher rule, for example, if this has like 300 priority, or like this NATing rule has a 300 priority, even then this NATing rule will be processed first. So when you create Azure Firewall, you can create different set of rules and you can define what traffic is allowed in or out of my network. So if a user is connecting over the internet, maybe you allow RDP connections, and you can define that RDP connection within your networking rules that you're creating over here. Okay, so you define all of these settings, what traffic is allowed and what is denied. Just like in your home, if you lock your home, right? Maybe you lock your home when you go out, or you're basically at night, you will lock your home. You don't want your doors to be open and anyone to enter and take away your valuable things, right? Similarly, you have a firewall. It is kind of a gatekeeper that helps you to prevent any attacks within your environment. Okay. So you have Azure Firewall, or you may also use third-party firewall as well. Maybe if you're finding that the cost is high on the Azure Firewall, you may go with any third-party firewall option also available to you. Okay. So when you're designing your network, you have these two options. There are a lot of other security options as well. We may discuss it later on, but from a network perspective, these are the major options available to you to prevent any attacks into your environment. Now, if a user is connecting over the internet, they may want to access some web application as well. In order for them to access some web application, you can deploy what is called as external load balancer. So you see this ELB, this external load balancer is a load balancer from Microsoft, which has a public IP assigned. If you have a public IP assigned on the load balancer, any user can connect over the internet and they can basically get access to whatever workloads you have over here. You don't usually deploy standalone VMs because you want to distribute the load between different VMs by using this load balancing solution available to you. So you deploy your load balancer, and this is deployed in the web server subnet. So you have two subnets created. You have a larger VNet. Within that VNet, you have created two subnets. One is your web server subnet. The other one is your database subnet. Web server subnet will get all the internet traffic. But what about the traffic which is internal? So if any private traffic goes to my servers, like database servers, how will you send the traffic to those database servers? For that, you have internal load balancer. So you deploy internal load balancer in order for you to basically manage the traffic internally within your network. Now there are different types of load balancers. If you want, I can make a separate video on it, but let me clear off everything. So you have a user connecting over the internet. They go either to the external load balancer. Once they are there on your web server, they're redirected to your internal load balancer. From the internal load balancer, the user may get connected to your databases, which are deployed in the private subnet. So this is your public subnet. And this is your private subnet created over here. Okay, so you're only talking to it over a private network. Now, besides this, you also have other configurations that you can see over here. So if any traffic is coming over the internet, you can also block some of that traffic by using network security groups. So we talked about some networking rules on firewall. The network security groups are somewhat similar to the networking rules at firewall level. Now, some of you are going to say why I have two options available to me. I've seen this question repeat a lot. Why not just have an NSG there, right? You're not paying anything for NSG. Why not just have this solution available to me? So whenever you talk about security, we always have defense in depth. So you basically fortify your castle so that nobody enters in your castle uh, easily. So you have multiple layers of security. So your first security layer is going to be like this firewall. But this can be this, let's say the lock at the gate of your home. So whenever someone is entering your home, that is the where you have your firewall placed. But let's say you have some jewelry. You keep that jewelry in some almirah, right? Or you lock it down into some rooms. This NSG is basically that kind of a lock. Okay. So it gives you the opportunity to store all of your, uh, it allows you to have your applications deployed, and you can define some inbound and outbound rules in this. So inbound rules can be, let's say, allow port 80 and 443. Outbound can be something else. Maybe you want to allow some traffic to DNS. So all of those rules can be defined, and based on those rules, traffic is either allowed into your network or not allowed in your network. So you have network security groups, NSG, which can also be used in order to secure your traffic as well. Now you have this option available to you. Now within network security groups, you have another concept called application security group, ASG. This application security groups helps you to logically segment your applications. So maybe you have some database application, you have some logical application. You want the traffic to go from this web server, let's say, to this database server. So what you will do, you'll create two application security group, and you will only allow traffic from this area to this area. You don't allow any other traffic, let's say, over the internet. So you can logically segment your network security groups by using application security groups. Now, by default, all of these networks that are part of, or all of these subnets that are part of the same network. Let's say if these two subnets are part of the same network, then these two subnets can talk to each other. By using what? Using something called as system defined routing. System defined routing. So with system defined routing, or you can say the default routing, they're able to talk to each other. But what if you have this subnet and this subnet wants to talk to this subnet? You want all the traffic, which is, let's say, going outbound, should go through a virtual appliance. So what you can do is you can define a user defined route over here. So you can define uh, a route table. So there are a few steps you need to follow to configure this UDR. Step one is you create a route table. Some people call it route, some people call it route, depending on which region you are. So you create a route table. After that, you add a route. And what that route is, you say define routing, where you're able to talk to both of these subnets. But if you want to say that the traffic which is going outbound should always go through some virtual appliance. So you have some network virtual appliance, maybe you have some firewall solution, maybe you have some other DDoS custom solution that you have created, or you have created some other solution where the traffic will be scanned before it goes out of your environment. Not DDoS, but I will say any other solution where you can scan your traffic. Okay. So any data loss prevention, DLP solution you have over here. Okay. So all of your traffic should be scanned from your firewall or your DLP solution before it goes out to the internet. You want that to happen. So what you can do, you define a UDR or you create a route table, you add a route, that is step two. And then the third step is you associate it with a subnet. So you have to follow these three steps in order for this routing to work. Okay. So you do all these three steps and your route will be configured for you. Okay. So you define a user defined route or the custom route, and this allows your traffic to go from this network to this network, or you can customize your routing based on your liking. So you have a layer 4 load balancer that we discussed about. You also have a layer 7 load balancer that works on HTTPS layer, which is called as application gateway. It has much more features. You can define multi-site routing. You can define multiple domain routing. You can configure your certificates. It works on application layer. So most of the features that you get with any application load balancer, you get that with application gateway on Azure as well. Also, uh, basically, it depends on what kind of traffic you want to send. If you want to send TCP, UDP traffic, then this ELB will be a good choice for you. If you want to send HTTP, HTTPS traffic, then this application gateway may be a better choice for you. So you have different type of load balancing solutions also available to you. So over here, you can place, you have another subnet. This is, let's say, subnet C. And on this subnet, you have your network uh, virtual appliances like intrusion detection, intrusion prevention devices, or it is your management subnet where you basically RDP into this management subnet and then you log into your backend subnets. So that can also be configured over here. Maybe use an Azure service called Azure Bastion. With this Azure Bastion service, you can basically define that connections over HTTPS. You connect over your web browser and you're allowed to connect to this backend from here. Let me clear off the screen to make it even more clear. So what this Bastion host does, it allows your users to connect over the internet. You can connect over public IP over your web browser, and it basically performs the NATing for you, converts your public IP into a private IP, and then this private IP is used to connect to any network in the backend. Okay. If you have some peered network, so if this network is connected to this network, you can also use the same Bastion host to connect to this network. From this network, you can hop to this other network as well. Since I'm talking about peering, let's discuss peering in detail now. So what is virtual network peering? In order for two virtual networks to talk to each other, what you do, you peer them. What is peering? Peering is basically you configure, this is a setting available on virtual network where you can define how your virtual networks are connected to each other. So you have two options. You have the regional peering option, or you may call it local peering, and you have a global peering option available to you. What is the difference between the two options? If your virtual network, so let's say if my virtual network is there in East US, and this is getting connected to another virtual network which is also there in East US. If both the virtual networks are in the same region, if you connect both the virtual networks together, this forms regional peering. And all of the traffic that you're sending from this network to this network travels over Microsoft Backbone. So Microsoft Backbone is used in order for the traffic to travel over here. Same case goes with the global peering as well. You're using Microsoft Backbone, but in this case, your virtual networks are part of different regions. So this virtual network, let's say one, is part of East US, and this other virtual network, Vnet 3, is part of West US. If you're connecting two different regions or virtual network of two different regions, this is called as global peering. Okay. Now, there is another way to connect two different virtual network, which is called as Vnet to Vnet connection. So if I want to connect two different virtual networks together, I have an option to called as Vnet to Vnet connection to connect both the virtual networks. In case of Vnet to Vnet connection, you'll require certain other things as well. You also require a VPN gateway to be deployed. If you see over here, a VPN gateway is deployed on this Vnet, let's say 4, and another VPN gateway is deployed on this subnet in Vnet 1. Vnet 1, let's say subnet 4. So you have another VPN gateway deployed, and these VPN gateway are used, or virtual private network gateway are used in order for you to send traffic over here. So if you want to send traffic from this area to this area, you use this VPN gateway. But in most companies, from my experience, what I've seen is most companies don't prefer VNet to VNet connection. They usually go with peering connection because peering connection is a much secure connection and it offers you better features in comparison to VNet to VNet connection. Because in VNet to VNet connection, you're paying an hourly cost for each of these gateways. So each of these gateways will have hourly cost associated with it. You're paying that cost. Bandwidth cost is there in both the cases. For peering also, you are paying a bandwidth cost. For VNet to VNet connection, you're also paying a bandwidth cost. But the overall gateway cost is going to be high in case of VNet to VNet connection. But one advantage you get with VNet to VNet connection is you can control the encryption. So whatever key I use on this side, same key I can leverage on this side as well. So that advantage you definitely get with the VNet to VNet connection. Now, let's talk about some other connection methods. So let's say if you are a developer, okay? So if you're a individual developer and you want to connect from this point, which is your laptop. So this is your laptop. You want to connect from this laptop to this site, which is the Azure site. And this is, let's say, East US site where your workloads have been deployed. In order for you to connect from a individual laptop or a point to site, you have to configure a point to site connection for this. When you configure point to site connection, you'll require a VPN gateway over here. And now you just like you use VPN, right? Virtual private network. Uh, you can basically use this in order to configure a VPN connection from this individual device or a point to this site as well. In terms of authentication, there are multiple ways to authenticate to this. You can use Azure certificates. So you can use certificates to authenticate. You can use Azure AD, which is the identity in Azure, or you can also use on-premises Active Directory domain services. You have to deploy a Radius server for that. If you deploy a Radius server, you can authenticate by any of these methods. Okay, so this is also a very popular method in order to connect any device like your mobile or your laptops to an Azure site. This is the second option in terms of connection. The third option available to you is basically site-to-site connection. Now, what do we understand by site-to-site connection? When this site, which is your on-premises site. What is my on-prem site? This is, let's say, any data center. So let's say I have a data center in Delhi. So if you have a Delhi data center, this specific on-premises site is getting connected to an Azure site. This is called as site-to-site connection. In this, you have to think about quite a few options or quite a few services. First is you deploy a VPN gateway. So the first thing you need to think about is deployment of a VPN gateway. And before you deploy the gateway, you have to create a gateway subnet. You create a gateway subnet, step one. Then you create a VPN gateway. Within the VPN gateway, you'll also assign a public IP to it because all of your traffic is going to transfer over the public internet. Although all the traffic will be encrypted by using some keys. Whatever key you use over here, similar key you're going to use over here. All the traffic, let's say, comes from here, gets encrypted because of the key that you're using over here. And using this key, the traffic is then sent over the public internet using this tunnel that you have created. So this protocol is also called as IKEv2, Internet Key Exchange version 2. This tunnel is also called as IKEv2 tunnel. So you create a gateway subnet, you create a VPN gateway, and you then create a public IP, step 3. Then you configure the on-prem customer gateway as well. So there is an on-premises customer gateway available to you, which is nothing but a router, let's say on-premises. It may be a Cisco F5 or any other router that you configure so that it is able to take traffic from cloud to on-premises and vice versa. This customer gateway will also have a public IP. This public IP will be updated in a service called as local network gateway. So you deploy this service in Azure, which is called as local network gateway. All the traffic goes from your VPN gateway to this local network gateway. From this local network gateway, the traffic goes to your customer gateway. And that is how this customer gateway is just this local network gateway is just an extension of your customer gateway in cloud. So you're just extending this customer gateway into cloud by using this local network gateway. So that is how your traffic transfers. So you deploy this local network gateway, and the last step, this will be step 5. One more step will be creating a connection. So you configure a connection. Once you configure this connection, these two sites will be able to talk to each other. Hence, this configuration is called as site-to-site configuration. You're connecting site 1, which is your Azure East US site, with your Delhi DC site, maybe. Okay. Although you will not deploy your Azure virtual networks and everything in a site so far away from you, you'll usually go for a nearest site. Maybe I deploy it in central India. Okay. So maybe this entire Vnet is deployed in central India, and then I'm connecting it to Delhi data center that I have over here. So this is another option, but this option does not offer you a private line of connectivity. If you want a private connection created for you, you use another service called Expressroute connection. In case of Expressroute, what you do, there are some Microsoft Enterprise Edge routers all over the globe. So you have Microsoft Enterprise Edge routers all over the globe available to you. Now what you do, Microsoft has already connected this Azure site with these Enterprise Edge routers. On your side, you work with a partner, some internet service provider. So this internet service provider, if you're in India, can be, let's say, Jio or Airtel or Tata. Any of these providers can be there. If you're in some other regions, maybe Americas, it may be AT&T. So these can be any internet service providers that you connect with. Let me clear it off. I'll draw a proper diagram. So you have this Microsoft Enterprise Edge router, and on this side, you have this Partner Edge router. So this is Partner Edge router. This Partner Edge router is then connecting to your on-premises router. So you are also getting internet from the same provider. This Partner Edge router or this partner has already made a connection with this Microsoft Enterprise Edge router. It is actually a cross connection. So you have one NIC card on this side, one NIC card on this side, and you have two NIC cards on this side. This NIC card gets connected to this one, and this one gets connected to this one. So you have a cross connection created over here in order to have a dedicated line to connect this site with this site. Okay. So if you want to have a dedicated connection, you go with this Expressroute connection over here. Just like in your home, you have your repeaters or your modems, whatever. You're having a dedicated connection to that modem, right? So you're having a physical line or fiber optic line connecting to that modem. In a very similar way, you have a dedicated line, and now all of your traffic travels over this dedicated line. It is not traveling over the internet, as was the case in case of site-to-site VPN. Okay, so that is the advantage that you get with this option. Now you have all of these configurations. You have a few more options in networking that I want to discuss today. So one of those options is called as service endpoint. Now, usually how your workloads are connected. So if you have, let's say, a subnet over here, right? And this subnet wants to talk to this storage account. How will it usually talk to this storage account? Let me show you the usual use case. Let me clear everything off. So usually what will happen is if this VM wants to talk to the storage account, you will go over the internet, and over the internet, it will come back and then talk to the storage account. Now, some of you are going to say this makes no sense. Both of them are part of Azure. Why not they talk to each other like this? In order for this VM to talk to this public IP of the storage account, we configure a service called as service endpoint. So what this service endpoint does, it creates a connection to this public IP of the storage account, and you're able to talk to the storage account. And all of this conversation happens over Microsoft backbone. You don't want this long path over the internet. You want the connection to be over Microsoft backbone. That can be accomplished by using something called as service endpoint. So service endpoint may be used in order for this connection to work. Now, if let's say you're going to say, why are we connecting with public IP? Is there an option to connect to the private IP of the storage account? I'll say yes, there is another option called as private endpoint. With private endpoint, what you do, if you want, let's say this database to connect to the storage account, you basically deploy a DNS. You deploy a DNS and you also deploy a NIC card. That NIC card is associated to some subnet and it gets a private IP from that subnet. Once it gets that private IP, your database connects to this NIC card and there is also DNS involved in this. This NIC card then gets connected to your storage account and you have a private connection established like this. So you have private endpoint options also available to you. So this was the major discussion on networking, or I wanted to highlight or summarize some of the networking components available to us. If you see on the left hand side, there are also a lot of integration options with virtual networking. You can integrate it with log analytics workspace in order to run some queries of your own, like you can run some Custo query languages. You can also deploy it on Sentinel, or you can connect it to Sentinel to improve the overall security posture of your network. There was also a service called as Security Center. Now it is called as Microsoft Defender for Cloud. You can use that to basically also improve the overall security of your network. And Network Watcher can also be used to troubleshoot any issues that you might be facing within your virtual network. So this was a brief summary of different components available in virtual networking. I may create a few videos deep diving into these different components available to us and maybe show you some demos along the way as well. If you want such videos and you find it valuable, feel free to subscribe, and you can also connect with me in any of the social medias that I've mentioned in the description. So thank you so much for your time, and I'll see you in a future video.